In this video we're going to be making high voltage with a flyback transformer, which is something like this. It's from an old CRT TV. So it produces high voltage rectified DC in the range of about 30,000 volts, and we'll be driving it with a custom circuit so we can do experiments with the high voltage. This is what the circuit diagram looks like. This is the simplified version because the complete version I'll put at the end of the video. So the supply voltage comes in and enters this primary coil of the transformer and is switched to ground through this MOSFET. The MOSFET gate is controlled by the 555 timer, which switches it on and off at a fixed frequency, and that creates pulses of current through this transformer, which is needed for its work. This diode protects the MOSFET gate from overvoltage, because overvoltage easily damages MOSFET gates, and this diode protects the MOSFET from overvoltage across its drain and source. And this is some more protection for the transistor, which consists of a diode, a capacitor and 3 neon bulbs, which clamp the voltage at around 270 volts in total. So let's have a look at how one complete cycle of the waveform from the 555 timer causes what's happened on the secondary side of the transformer. So when the 555 timer produces a high level, the MOSFET turns on and current starts flowing in the primary. At this point in time, the voltage across the primary is in the polarity shown on the diagram, and that causes a polarity to appear across the secondary coil like this. But nothing happens yet on the secondary side because this diode stops current flowing in this direction. And when the MOSFET turns off, the inductive kickback causes the polarity to switch like this. And this time the diode can conduct and the transformer dumps its stored energy into the arc, which happens here in this spark gap. Okay, so I've got the circuit set up here, and if we turn it on, then we can see that our 555 timer, which is this chip here, is generating a square wave with a frequency of about 26 kilohertz. So now let's take a look at the output of the high voltage transformer. As you can see, this is very weak. This is because the frequency is too high. Now I've decreased the frequency to around, let me zoom out, around 3 and 2.5 kilohertz. Now let's take a look at the arc again. As you can see, it's much more powerful. So I've decreased the frequency even more, and now the arc is way more powerful and longer. Okay, so this is the end of this video. I hope you enjoyed it, and I'll see you next time. Bye.